Welcome to Otisam Mathematics. Thank you very much for always watching my videos. In this video, I'm going to look at binomial expansion. Find a term independent of p of the binomial, bracket open, p minus 1 on 2p, all raised to the power 12. Now, care must be taken in solving this question. Or look at this p here. P is found in the first term, and then p is also found in the second term. So what you have to do is to rearrange so that all the variables will be together. Now, to do that, we use the general term of binomial expansion. So the general term is n combination r dot a to the power n minus r times b to the power r. Now, where a is the first term of the binomial, b stands for the second term of the binomial, n is the number of terms. Of course, r is the specific term that we'll be dealing with. In this case, we don't know the specific term that we are dealing with. That's why it is important to put all the variables together so that we can find our r. Now, from the question, our a is equal to p, that's the first term of the binomial, and then b is minus 1 on 2p. We have n is equal to 12, that's the number of terms. Let's substitute them in the formula. So n combination r times a to the power n minus r times b to the power r now becomes n is 12, so 12 combination r, we don't know r, times the first term is p raised to the power 12 minus r times the second term is minus 1 on 2p, so minus 1 on 2p all raised to the power r. The motive is to put all the p's together. How do you go about it? We use the concept of indices. So let's go to 12 combination r times p raised to the power 12 minus r times, and this r here is affecting everything in, so we can rewrite minus 1 on 2p as we split them. Now, according to indices, a, b raised to the power m, the same as a raised to the power m, b raised to the power m. So this one we can write it as 1 over p all raised to the power r times minus 1 on 2 raised to the power r. So then 12 combination r times p raised to the power 12 minus r times, and this one we can rewrite it by indices. Bring the power up, minus r times minus 1 on 2 raised to the power r. So we have 12 combination r times. Now the bases are the same, so we can put them together. P 12 minus r minus r, we have 2r times minus 1 on 2 all raised to the power r. Now we want to look for a term independent of p. A term independent of p means p to the power 0. P to the power 0 is 1. So for a term independent of p, the power of p must be 0. That is p to the power 0. Equate this exponent to 0 to find the r. So then 12 minus 2r is equal to 0, which implies that 12 is equal to 2r. So we divide both sides by 2 to find our r. So here 6. So r is equal to 6. So when r is equal to 6, then we are going to have a term which is independent of P. We are going to find 12 combination. We know R now. 6 times P to the power 12 minus 2 times 6 times minus 1 on 2 raised to the power 6. So 12 combination 6. When you use the calculator, we are getting 924 times. This will be P 12 minus 12 and times. Now it's minus 1 on 2 raised to the power 6 because it is even power. This one will be positive. So we are going to have 1 over 64. So which is 924 times P to the power 0 times 164. So we are getting 924 over 64. And P to the power 0 is 1, which is equal to, when you simplify, 231 on 16. And if you want to go further, then it will be 16 into 231, a 14 whole number, 7 on 16. That is the answer. So a term which is independent of P is 14 whole number, 7 on 16, or 231 on 16. Thank you very much for watching this video. I hope you have enjoyed it. If you have not subscribed, just kindly click on the subscribe button. You can also turn on your notification button so that anytime I drop a video, you can have access to it.